at Energy Storage Europe. I'm Jonathan Gifford, the editor-in-chief of PV Magazine. I'm joined by Lorenzo Grande. He's a technology analyst with IDTechEx and has been looking into different storage technologies, but in particular Redox flow batteries. It's a technology that's relatively mature in the market, but how would you say deployment is going? Who's actually using Redox flow batteries and for what applications?
So it's a very interesting technology to analyze because it's actually been in the making for several years. It was first developed by NASA for their aerospace applications, and then it somehow fell to the more common and more successful lithium-ion technology as well as lead acid. And it's now make a comeback after in 2006 some patents expired, originally developed by the University of New South Wales. And starting from then, many companies in Europe, Asia, and as well as in the US have started working on this technology, particularly the one based on vanadium redox flow batteries. And since then, there's been an explosion. But now it's time to see when it will actually make it to the market.
And so what kind of installation numbers are you hearing? Are people actually using redox flow batteries?
So there's a Japanese company called Sumitomo Electric, which claims to have already installed 104 megawatt hours worth of flow batteries worldwide. Other companies in Europe, like Gildemeister, Schmidt, have more modest numbers when they disclose them. In the US, it's very interesting to see a very interesting company to follow is called the UET, and they are a subsidiary of a Chinese company called Ronqi Power that is actually in the steel industry. And vanadium is a component that is added to steel, so it can also be used for flow batteries. And this is how they Ronqi Power and UET try to make a business case to make it commercial. And UET and particularly Ronqi Power are involved in currently the largest battery under construction in the whole world, which was located in Dalian Peninsula in China. And this battery will have a peak power of 200 megawatts and a rated capacity or energy of 800 megawatt hours. So it's a small power plant.
So it's a very big battery system, yeah. Indeed. And what is then the business case? What is the use case for flow batteries, vanadium redox flow in particular, as opposed to lithium-ion, which you mentioned also and is very evident here on the trade show floor?
Yeah. So lithium-ion batteries are cheaper at the point of purchase, but then their capacity and performance degrade over time quite steadily. Flow batteries are a bit more expensive at the beginning, so the capex required to install such a system is higher than for lithium-ion, but then they retain their performance for a longer period of time. So the main business case that I've heard from companies I've interviewed revolves around making it cheaper in the long term. So these systems these stationary batteries are supposed to be installed for 10, 15, even 20 years. And those people who make these investments, they want to make sure that they don't have to pay any extra money in 10 years' time if there's a rupture or a system breakdown.
And what are your expectations for the technology? You know, as we've been saying, it is a mature technology, but perhaps we're not seeing the growth levels when compared to lithium-ion.
Yes. Well, another technology that is directly competing with flow batteries is that of sodium sulfur, or the so-called zebra batteries, which have also been around for a number of years. Some drawbacks are related to their high operating temperatures. So these sodium sulfur batteries operate above 300 degrees C. And a couple of years ago, a company called NGK Insulators, which is based in Japan, had a problem with one of these batteries. There was a huge fire, and they spent $600 million ever since then to replace all the faulty batteries around the world. Now this technology is making a comeback, and it will directly compete with flow batteries, which are also mature for the market.
So it's not so much a head-to-head with lithium-ion then, which has applications in our consumer devices and in e-mobility, but also in stationary storage.
Yes, so among the large-scale batteries, I would say sodium sulfur is the direct competitor, and lithium-ion is obviously most of the companies that develop stationary lithium-ion systems are doing this also because it's a way to create the industry that in one day will lead to widespread electric vehicles. We've seen here at the show, for example, Mercedes-Benz has a huge booth where they promote their residential storage battery, and it's quite unheard of that a car company behaves a bit like a utility. That's a similar business model to Tesla, for example.
But we won't see any Redox flow batteries in cars anytime soon, sloshing around in the bottom of a car, I don't imagine.
This is a very interesting question, remark. Yes. So back in the 80s and early 90s, there were companies actually developing zinc-bromine flow batteries for automotive applications. One of them was installed in a van to deliver mail in an Austrian village. And last week I attended a presentation by EDF, which is the French energy utility, which has also developed a zinc-bromine battery with very high energy density, and they at least suggested the audience that this battery could be used for automotive applications too.
Wow, okay, always something to learn and shouldn't be underestimated, any one technology. Lorenzo Grande, who's a technology analyst with IDTechEx, thank you very much for your time here in Düsseldorf on the second day of European energy storage.